Hello everyone, welcome back to my YouTube channel. For those of you who don't know me, my name is Adrian Corral. First, I'd really appreciate it if you guys will like and subscribe, and well, let's get started. Today we're diving into an essential concept in operating systems called interrupts. Have you ever wondered how your computer multitasks efficiently, or how it responds instantly when you press a key or move the mouse? That's all thanks to interrupts. In this video, we're going to break down what interrupts are, why they matter, and how they work. So let's get into it. First, what is an interrupt? An interrupt is a signal that tells the CPU to pause what it's doing and handle something important. Think of it like getting a phone call while you're watching a movie. You pause the movie, answer the call, and return to your movie. The CPU does the same but with interrupts. There are two main types: hardware interrupts and software interrupts. These interrupts are what keeps your system responsive and efficient. Your CPU would waste time checking devices constantly, which makes multitasking slow and inefficient. Interrupts help by improving system efficiency, allowing real-time responses to critical events, and enabling multitasking and parallel processing. Interrupts come in different forms, and each has a specific purpose. Maskable interrupts can be delayed if needed. Non-maskable interrupts are critical and cannot be ignored. And exceptions are errors like dividing by zero or accessing invalid memory. When an interrupt occurs, the CPU follows a step-by-step process. Interrupt request generation, which a device sends a signal to the CPU. Interrupt controller manages priority and sends it to the CPU. And interrupt service routine, a special function that executes the required task. Let's see what happens when an interrupt occurs. The CPU receives an interrupt signal, then it suspends the current task and saves its state, then it determines the interrupt source, then the corresponding ISR is called, then the ISR executes the required task, and the CPU resumes its previous execution. All this allows smooth execution without data loss. But not all interrupts are treated equally. Some are more important than others. The interrupt vector table assigns numbers to different interrupt handlers. Higher priority interrupts preempt lower priority ones. For example, a keyboard input takes precedence over a background task. Older systems used programmable interrupt controllers, but modern computers use advanced programmable interrupt controllers for better performance. Software interrupts allow programs to request services from the operating system. For example, system calls for file operations and memory allocation. In Linux, int0x80 is used to invoke system calls. Sometimes interrupts happen due to errors. Some examples include divide by zero errors, invalid memory access, the Windows blue screen of death, which is often caused by unhandled exceptions. Interrupts enable content switching, allowing the CPU to switch between tasks efficiently. It works like this. The CPU saves the current process state, it processes the interrupt, and restores and resumes the execution. Interrupts are everywhere in computing. Some key examples are operating systems like process scheduling, embedded systems in real-time automation, and networking in handling data packet transmission. So overall, interrupts are crucial for modern computing. They help keep the CPU efficient, allow real-time responses, and enable multitasking and parallel execution. Understanding interrupt handling is key for anyone learning operating systems or computer engineering. So if you found this video helpful, hit that like button and subscribe. And thank you all for watching, and I'll see you in the next one.